Welcome to our webinar, our Techspray webinar. It's replacing N-propyl bromide. What you don't know can hurt you. Okay, we're going to be going over issues with N-propyl bromide and how to identify and qualify replacement as efficiently as possible. Okay, you guys aren't chemical experts, at least I assume you are. There may be a few out there. So the idea is to arm you with whatever you need to be able to work with the experts to find a solution, okay? Without going back and forth, we're going to give you the tools you need, the information you need to work with these guys, including us, of course. Of course, you know, got to be open to it with you. We want it to be us. We want you guys to work with us. All right, so first, let's cover some quick housekeeping. Okay, we're going to save the questions to the end. Okay, so the last 15, 20 minutes, if you have a question, use the Zoom controls under questions, okay? You can use chat as well. I would rather use questions because I tend to miss it if it's on too many screens. So if you can use questions, I'd appreciate it. Type one, submit it, and at the end, you know, we'll answer the questions. If we don't cover everything, I'll send an email with the answers to the question. Now, if you've got some proprietary kind of question, okay, just mark private on it. I won't answer, we won't answer that question here. We'll follow up with you later, either by email, phone call, or whatnot. I don't have your phone number. You can always put that in the message, but but I do. You have your email. Of course, we're going to provide you our contact information. Okay, so you can get back with Pierce or me on anything else you're dealing with, because that's our job, is to work with you guys. If you raise your hand, Zoom, using all the cute Zoom controls, we're not going to pay any attention. There's too many of you. If everyone's waving their hand, we're not going to answer questions. We're saving that to the end. I hope hopefully you understand that. And there was a poll to begin with. Hopefully you took the poll, okay? And I'm going to go over the responses to that. And at the end, there's a survey, okay? I believe you have to go up to the survey section. It may pop up, but if you can please take that, it'll take you maybe 1 minute, 2 minutes tops, and give us some feedback on this. I'd really appreciate it. Okay, so now let's go to the poll. Okay, so about 12% of you are using N-propyl bromide. Okay, so just gives us a feel of who's, you know, who we're talking to here. We've got a number of different types of people. So 12% of you are using N-propyl bromide, and strangely enough, 15% of you are looking for an N-propyl bromide replacement. So don't quite understand how there could be more people looking for replacements than are using it, but that's fine. So definitely, if this is for you. If you're looking for replacements, we're going to be giving you great tools that are going to help you do that. Okay. So now for some introductions. Okay. First of all, we got Pierce Pilon. Okay, Pierce Pilon is our main speaker today. Okay, senior field engineer, and he was managing our lab for about 18 years. Okay, so he's been doing this a long time, but now his job is to get out in the field and help all of you out. Okay, so take advantage of that. Okay, that's what he's there for. So he flies all around the country solving problems. Okay, and Pierce actually started about 6 months before me. So we've been both at it for about 18 years. Before that, he worked for a petroleum industry, Getty Oil, Chevron. He's very active in SMTA and IPC, having served on various boards and committees, okay, in addition to speaking at conferences. He's also served as executive capacity for the Southern Aerosol Technical Association, or SATA. Okay. Now, I'm Kevin Pawlowski. I'm in marketing, but I'm also your application specialist. So if you call in, if you email, if you chat, okay, generally you're going to be talking to me. And like I said before, I've been at it for a while. I've seen a lot of places. I've been all over the world looking at different applications of our products. So I can generally give you a lot of good information. It gets too technical, of course, then I'll bounce it over to Pierce. So we work together all the time. So with that, let's turn it over to Pierce.
Well, thank you, Kevin, for the introductions, and welcome everyone to the webinar. Good afternoon or good morning if you're on the West Coast. There's a lot of information here. I hope you find it of value, whether you're a current nPB user or you're looking to replace that in your processes. So there's a lot of information here and a lot of territory to cover. So let's go ahead and get started. So I'm kind of following the slides here and talking. So nPB, what is it? Okay, well, you're going to hear a variety of names for the same material. It's known as nPB or N-propyl bromide, 1-bromopropane. You'll hear it as 1BP sometimes. The solvent is flammable, or I'm sorry, excuse me, non-flammable, fast evaporating, but it does have a reasonable dwell time. And it's been shown to be effective on a variety of soils. Primarily, you'll see it in flux residues, greases, oils, some waxes. And you'll see it as a constituent in aerosols, manual cleaning, ultrasonic cleaning, and of course, vapor degreasing. It's been very popular over the years in machining facilities for parts cleaning. It's used in almost any conceivable cleaning method that you can imagine. Notably, it's been shown to be aggressive to many elastomers, or as Kevin says here, the rubbers, when he built the slides. These include seals, O-rings, things of that nature, and some plastic substrates also. Okay, so why do people use nPB? Well, a little history. About 30 years ago or so, Freon 113 or CFC 113 was used everywhere, and it cleaned everything. It was non-flammable, plastic safe, and it was a very powerful cleaner. As time went on, they also found, unfortunately, that it depleted the ozone, which was a big deal a number of years ago. And so the CFCs, or the chlorofluorocarbons, as a class, were the first group to be listed as ozone depleting substances by the EPA. And the CFCs were therefore banned and prohibited from use in 1994. At that point, the market split. It split into non-flammable critical cleaning, non-flammable industrial cleaning segments, and of course the flammable cleaning areas. The non-flammable industrial users eventually made the move to TCE down the road due to cost. And then later on, many of these TCE users switched to N-propyl bromide due to the safety and environmental issues that were then known to be associated with TCE. Okay, problems did emerge with nPB. In 2007, the EPA approved nPB with certain use conditions for metal cleaning, electronic cleaning, and precision cleaning. These were under the SNAP rules. If you're not familiar with SNAP, it's actually a caveat of the Clean Air Act, and it stands for the Significant New Alternatives Policy Program. So, as with most things, the more we use it, the more we learn about it, and nPB was no exception. It was widely marketed as a safety solvent, and it was used in almost every imaginable type of cleaning method. Now, as time went on, further studies, as these happened, showed it to be a carcinogen or a potential carcinogen, and along with negative effects on neurological and some reproductive systems. Now, back in the day, it was somewhat common to hear complaints ranging from headaches to short-term memory loss to motor function degradation over the short term. And this was seen to be very common in vapor degreasing operations, as well as many adhesive applications where they used nPB as a carrier solvent. Okay, let's learn a little bit about toxicity and how that toxicity is expressed in the different forms of documentations that you'll see. On an SDS, the safety data sheet, you'll see a variety of abbreviations: OEL, PEL, REL, TLV, TWA, OSHA, ACGIH. Don't let all these abbreviations scare you. There's a ton of agencies that study these materials and express the limits with different nomenclatures. And we'll go over some of these shortly. OEL is occupational exposure limit. PEL is permissible exposure limit. Essentially the same, different agencies just use different abbreviations on how to express that. REL is recommended exposure limit. You'll see that mostly by the manufacturer of the products in the absence of other data, especially when the product is new to the market. They will put their own recommended limits on it. TLV, threshold limit value, that's the top limit that you cannot exceed. TWA is a time-weighted average. That's usually for an 8-hour period, which coincidentally is the usual length of a work shift. OSHA, everybody knows OSHA, the Occupational Safety and Health Administration. And one of the many things that they do is they administer and they set the rules and limits found in the SDS document. Now, the SDS document is actually a federal document. It's an OSHA document. As manufacturers, we prepare this document, but we have to follow those rules set by OSHA in 29 CFR, which is the Code of Federal Regulations. Lastly, the ACGIH. This is not a government agency. It's actually a third-party private agency. It's the American Conference of Governmental Industrial Hygienists. And this is kind of the way it works. The ACGIH adopts a TLV based on their 8-hour TWA studies and their testing data. Now, OSHA normally, not always, but normally adopts the recommendation values from ACGIH and then incorporates these as the limits in the SDS. So originally ACGIH had set the 8-hour TLV of N-propyl bromide as 10 parts per million. Later on, they published what they call a NIC, an NIC, a Notice of Intent to Change or to lower that value. And after many years, in 2014, they officially adopted and lowered their recommended value to 0.1 ppm. They went from 10 parts per million down to 0.1. Now, in one of the very few cases that I mentioned where OSHA has not followed the ACGIH recommendation, OSHA has yet, after all these years, they have yet to establish a permissible exposure limit. If you see in the toxicity section of an SDS, if it shows OSHA PEL, you'll always see, at least at this point, not established. They have never established a limit. Now, in one of the cases, or in this particular case, you may actually see it changing soon. Kevin?
You need the next slide, Pierce?
Yes, please.
Oh, okay. Sorry, everybody. But what about that last bullet, though? That actually is an important one.
Well, yeah. In many of the processes by regulation, and especially in different state regulations, it's hard to get down and maintain your process below 50 parts per million, even with vent hoods, spray booths where they have, extreme ventilation. So if you're looking at something that is set, the limit or recommended limit is 0.1 ppm, and you can't even maintain 50 ppm, then you're probably way out of bounds for your operators and any bystanders that may be. Sorry, I skipped that part.
Oh, no problem.
Okay. Now, as I said, that this may all change very soon. In August of this past year, the EPA released a non-technical risk evaluation of N-propyl bromide in various applications. They evaluated nPB in 25 different use conditions. And out of that 25, they found 16 different specific use conditions where nPB was used that presents an unreasonable risk of injury. Not my words, that's their words, an unreasonable risk of injury. So now they further separated these into 9 industrial and commercial uses and 7 consumer uses. Now, among all of these industrial and commercial uses of nPB, there's just common cleaning and degreasing methods, including vapor degreasing like open top inline closed loop systems, cold cleaning methods, and aerosol uses. Automotive degreasers that such as engine degreasers and brake cleaners containing nPB were also among this list. And the list goes on. It's a pretty significant list. And if you have not read this document, I encourage you to go online and view it. It separates all of the reasonable uses and unreasonable uses where they find that there is risk of injury to the operators and the bystanders.
Yeah, let me break in there. If you want to link to that EPA document at the Techspray website, techspray.com, under blogs, we have an article about this. In that article is a link to the EPA document. Okay, so that's a really easy way to get to it. I'll send a link with everything else after this. So if you're attending, you'll get a link to this, and we'll make sure that you'll have it so you can review that on your own.
Okay, wait a minute, Kevin. As a follow-up to the summary, the EPA is initiating a process to look at these unreasonable risks that have been identified in this summary, and they have 2 years to address each of these identified risks by rule, which means that once they publish this in the Code of Federal Regulations, it becomes law. So just my guess, and this is just me talking off the cuff, my guess is that once this happens, you're going to see some revision of the SNAP rules and the restrictions on the use conditions regarding nPB, and perhaps even some modification of the Clean Air Act itself. So that may be coming within the next 2 years. Okay. Okay, so where do you go from here? Are you considering replacing nPB in some of your processes? How are you going to set up the evaluation and that decision-making process when you're looking at a variety of replacement chemistries? Well, hey, you're in luck. We're going to give you some guidelines based on our experience on how to go about this. Now, you may find that you need to modify our techniques and recommendations somewhat to fit your specific process and situation, and that's okay. But what follows are the guidelines that we employ, and they just may not be right for everyone, but it will give you an idea of how to organize your procedures. So what are the target parameters that you want to consider for evaluation? Well, some of these conclude just what's listed here. The method of application, toxicity and emission values, the flammability of the product, materials compatibility, other specifications that you come up with that you need to review and evaluate, and of course, performance. And last but not least, cost. Cost will always be a factor. Now, this may or may not be your primary concern, but it is our suggestion that you consider this cost lastly. And the only reason I say that is because we've seen a number of times where a customer has, during his evaluation process, has written off a number of competing products that he's comparing just due to cost. Well, eventually they find themselves boxed into a corner with no replacement chemistries. So if you find that you have more than one replacement chemistry that are fairly even in the target parameters that you set, and they're all even other than cost, well, that's a fairly easy decision to make. However, if they're all pretty even in including cost, well, then it comes down, you need to prioritize your targets and make a risk assessment based on the priority of that.
All right, I'm going to, if you don't mind, Piers, I'm going to go ahead and step in here. I had emailed earlier this morning some links for you guys. Now, you don't have to open those up now, but if you do, that's great. Basically, I sent you two links to two documents to help you in this qualification process. Okay, so what Piers is going to be going through is step by step what you're looking at. And these tools are to help you in that process. Okay, so starting out, hopefully you can see that. Okay, so we've got a form here. Piers, can you see that?
Yes.
Okay, just making sure. So you have a form here. It's a specification form. Okay, so the idea here is you get with your chemical supplier, let's say your current chemical supplier, and you need to get the specs of what you're currently using unless you have that already. Okay, and the key to this is you go to either your current supplier or other suppliers. They need to understand what you're currently using. Okay, that's the default. That's sort of the baseline that they're going to be going off of. And so this form gives you a way to do that without playing 20 questions, going back and forth 20 times before you finally get to it. Okay, so you can get this to your current chemical supplier, have them fill out the gray areas. Okay, so that is your current specifications. And so then you send it to another chemical supplier. Let's say you send it to us. We look at it and we're going through and okay, here is what you're using in terms of your product. Okay, application method. Okay, the more we can understand, we may have other questions, but this will give us a good base information of what we're dealing with. And so what does your process look like? Well, here's some fill in the blanks. Okay, you can check things off and you can fill things in to make it really easy then for somebody to get back to you. Then have the supplier fill in the part in white. So you're going to supply them what's in gray, they fill in what's in white, and then when you're done, you've got their recommendations. Okay, so you can see it goes down to toxicity. It happens to follow the slide Piers just went through. Okay, so we're going to be taking you through step by step on that. And of course, ending in cost. Okay, and there is the opportunity to add other cost advantages because as we all know, it's not always just dollars and cents. Okay, so then we go to, you get these back, let's say from 3 different suppliers. Okay, then what you have is a worksheet. Okay, the worksheet, it's an Excel spreadsheet. Okay, so you know most of you will know how to use Excel. You can make changes as needed. Okay, add the product names that you want to add, fill in the blanks from the forms. And this will give you an opportunity to do a comparison study. Okay, so you've got all of these specifications across, and so you can see them side by side. So you can decide which one works best for you. Okay, so as Piers mentioned, you look at the quoted price. You can go to the lowest one as long as everything meets your accepted criteria. Okay, so this column C is your current product, and if everything meets the same specifications, well, it should work in your process. Okay, so the idea is to really slick up the communication with your chemical suppliers. Okay, so let me get this back to the slide. All right, Piers, back to you.
Okay.
Just one second. Sorry.
That's okay.
Jumped ahead a little bit. All right.
Okay, here we go. Okay, so let's look at the various application methods that you may be currently using. Now, each of the replacement products that you're considering are going to have their own pros and cons, depending on how you employ those products. So here's a few things to consider on each, and we'll dive a little bit deeper on each of one of these in the following sections. So for vapor degreasing, you want to compare the various physical properties of the competing products. What are the different boiling points? How will these different boiling points help to remove the soils? Because you'll notice that in many of the ones, the newer formulas are typically going to be lower boiling points than nPB and some of the older methods. What type of retrofit may be required for the new chemistry? Is the unit on its last legs? Is it worn out? Is it time to replacement? Is your unit compliant with the regulations in your state for all of the emission controls? You know, this could be the right time to either repair or replace your unit. For ultrasonic cleaning, compare the properties of the products under consideration. You know, if possible, choose those for comparison that you know are well used in a in an ultrasonic or for manual cleaning. Not all products work very well in ultrasonics. And again, emissions is an issue with these models and with these methods. So be sure to check all of your regulations. Aerosol cleaning, well, as you've probably guessed, any product that is aerosolized will exponentially increase the exposure of that product to the operator and the bystanders. So be aware of the ingredients, research these ingredients, and research the effects of those on your workers. Okay, now to go a little bit deeper into vapor degreasing. If you're not familiar with the process, and obviously a number of you are, but for those of you that are not, it's a closed loop system. And essentially it's a boil, reflux, and condensation loop that regenerates that solvent or condenses that solvent and then replenishes the section that provides the cleaning area, which in this case is the boil zone. Now, the solvent chemistry should be an azeotrope or a near azeotrope in order to maintain constant or nearly constant composition and stability in both the liquid and the vapor phases. This is for number one, for safety and consistency in cleaning. For the typical application, non-flammable products should always be used in a vapor degreaser. Now, compared to your current products, the boiling point will probably change in your replacement chemistries that are under consideration. In the newer chemistries that we typically see, the boiling points are generally lower. When switching to a new chemistry, it will be important to optimize your system and to achieve the best performance values and to meet your cleaning requirements. And it's very rare that you can just drop in a replacement chemistry and use the same setup and the same cleaning parameters. Your software will need to be adjusted, your temp points, your safety cutoffs, all that, your refrigeration levels will all need to be re-entered. And we can help you with that, but there's more to come on that later, as you'll see. So for ultrasonic cleaning now. For ultrasonics, we always recommend, again, using non-flammable solvents due to the possibility of emission escape that's really almost inherent in these types of units. Flammable emissions or vapors can escape, move around the area, and potentially come in contact with a heat source or an electrical source and cause ignition. So for various chemistries that you've got under evaluation, you want to vary the dwell time in your testing. And then that way you can see the different results. And that will help you to optimize that process for the maximum cleaning performance and your throughput. Adjusting the frequency usually is only going to be feasible by changing the model or the unit and or its transducer. It's going to be much more difficult to change the transducer. It's really not an option. It can be done, but to safely and reliably change out the frequency, it's just easier to purchase a new model with a correct transducer in it. You can consult with your equipment vendor, explain the parts that you're cleaning, as well as the chemistry that you're using, and they can help you choose the right transducer option or a different model with a different transducer option, as well as the capacities that you need for your process. Now, increased heat input generally improves cleaning performance. That's kind of a rule of thumb. However, in ultrasonics and other methods that you'll see, that also usually increases your product loss, and it will increase the associated makeup cost. So manual cleaning like dip and wipe or other such methods will also be subject to emission loss, and then subsequent operator exposure, product loss, makeup cost. So just be aware of that. If you're looking at replacing chemistry in an ultrasonic, the bath loading is probably going to change with a different chemistry. So you should monitor that closely. You should set up some trend sheets to establish a frequency based on your throughput for replacing the liquid in that bath. And for the bath use, we generally recommend a final rinse once you remove the part with a clean or virgin solvent that you utilize. So think about it. You put the first parts in and they come out and they're nice and clean. Well, what's left is dirty solvent. Doesn't mean it's loaded, doesn't mean that you can't use it, but now you've got residues and particulates in that bath. So you lower your next set, and every subsequent set that solvent gets more and more loaded, more and more dirty, and that just increases the potential for redeposition of some of these soils back onto your parts as you raise them back up. That's why we recommend a final rinse with clean solvent, just to remove anything that may redeposit on those surfaces. Aerosol cleaning, okay? It's important to look in an aerosol cleaning at the spray pattern and the variations of that spray pattern that you can use to improve your cleaning methods. Now, some products use what we call the fire hose effect. Not only is the solvent in the aerosol dissolving it, but the pressure behind it, the jet stream or the spray pattern, the smaller patterns help to dislodge the soils at the same time. You'll see that most of these aerosol cleaners come with an extension tube or a straw, as we call them. Using that can really intensify this localized effect where the spray is much more effective. Now, again, one question to ask is, do you really need a non-flammable aerosol? Okay, of course, that's always on the wish list, but consult with your ESH team, consult with your purchasing agents, because one area of concern, again, is always going to be cost. And a non-flammable product will always add a premium to the cost of that product. So if your facility is set up with proper ventilation, safety procedures, hey, a flammable aerosol might be acceptable and provide the required cleaning results. Now, some have seen this phenomenon where the substrate gets chilled and it actually frosts up. It looks like ice on your board, okay? And that's caused when you're using an aerosol product, and those propellants, the gas in the aerosol that forces that liquid out of the nozzle, those evaporate extremely quickly, and that causes a surface cooling effect on that board. And what happens is it chills so quickly and to such a point that it can condense moisture from the humidity in your facility, and actually it looks like little snow or frost on your components. And the way to get away from that is just back off on the distance a little bit. That gives the propellants adequate time to dissipate before they actually hit the board entrained in the liquid. So now, some aerosols come with a brush attachment, Okay, so if you're using the brush attachment with the aerosol or some other method of outside agitation, like a separate technical brush that you're using to loosen the soils, a final rinse again is always recommended, because when you're using a brush, yeah, you may be dislodging the soils and dissolving them, but you're really just moving them around from point A to point B. You're not getting them off the board. Once you've got everything loosened up, you're pleased with how it's looking, rinse that board or that part from top to bottom with the aerosol, and that will give you a final rinse of everything off of that board.
Hey, Pierce, I'm just going to give you a 10-minute warning on it, okay?
Okay. Toxicity, okay? First, we recommend to avoid TCE or trichloroethylene and perchloroethylene or PERT. Both of these have used restrictions. That's going to affect your reviews and the process that you're organizing for these comparisons. So it's always a good idea to review the SDS, your technical documents for the products that you have under evaluation, for the various limit values that are going to affect your operations. Replacement chemistries, we recommend those to be in the 200 plus parts per million threshold limit value, based obviously on an 8-hour time weighted average. So consulting with your ESH group is always a plus, because you don't want to go through all of this testing and then now you've made your decision and then your ESH guy comes up and goes, wait a minute, we can't use this. So avoid hiccups like that. Keep your ESH team in the loop. Now, you may feel it's necessary. You can employ an industrial hygienist to do some exposure testing while you're doing your performance evaluations. That will give you some real world idea of the amount of material that you're putting into that facility and the risks involved in the new products and compared to your older products before you make that decision. Obviously, wearing the appropriate PPE is required, and much of that information, you can find on an SDS, as well as conversations with your chemistry vendors. We can help you with that. If there's ventilation requirements, if there's a turnover rate in your facility for the air that's needed, your process engineering staff can help you guide you along in that. Now, in a quick way, just to simplify, areas of concern, if you look there in that top picture on that label, you can see some of the little pictograms. These are the same ones that are used on an SDS. Ones that you might want to be wary of is the exploding chest. That's what we call it, the exploding chest pictogram. So that's just a beware. Okay.
Yeah, let me clarify that it doesn't mean the chemical is going to make your chest explode. That's
No.
chronic. That's a chronic hazard. So basically, not necessarily a carcinogen, but it could include carcinogens. It's just something to be aware of if you see it. Any of the N-propyl bromide products would certainly have this. And of course, the objective is to move to a safer one. So just make sure you're not moving into another type of hazard.
Okay, so one of the main things to realize is that the more stringent your emission requirements are, the more that's going to affect the bottom line cost to your operations. From the chemistry you choose, to the equipment that you use, to the requirements on that equipment, and to the record keeping that's required by regulation. And that record keeping is incumbent on the end user, not the manufacturer, you. And that's an incredible amount of time. So the less record keeping you can do, the better. So you need to evaluate and weigh the environmental benefits to the amount and the type of solvent that you choose. For example, a product may meet all of the required environmental regulations, but if it doesn't meet your cleaning requirements, well, it's kind of a useless product for your process. VOCs, volatile organic chemicals. The requirements vary from state to state and even among a lot of the local municipalities. Everybody has heard that term, VOCs. So make sure that you check all the sources of regulations for compliance. Usually you'll see the amount of VOC units. They will be expressed in either product weight percent or grams per liter. So your ESH team can help you with that information to ensure that you're compliant in your choice. If global warming is an issue, and this might be a requirement through a regulatory rule or an internal company policy, a lot of that information can be provided by the product vendor. That's us. But be aware that there's various additions of these figures, so make sure that you're comparing apples to apples. In effect, they use CO2 as a reference of 1. That's the baseline. So the global warming potential of your different products is based on a 100-year degradation, and is compared to the baseline, which is 1 and carbon dioxide. So in propyl bromide, as a rule, and I mean by rule, regulation, is considered a hazardous air pollutant, or a HAP. So if you're looking at replacement chemistries, try to avoid replacing one HAP with another. That just adds another headache to deal with. So if you can avoid less record keeping, that's a plus. If you're doing business in the EU, if you're importing materials to the EU, some of their restrictions may apply to your final assembly. I'm sure you've heard a lot of these: REACH, ROSE, SVHC. That substance is a very high concern. That's a subset of REACH. So if your company is applicable or subject to the EU directives, be aware of which of these may apply to your replacement chemistry. Flammability. Okay, so to reiterate, making a product non-flammable results in a premium cost to the customer. So is that required or just desired? So except for extremely special operations, vapor degreasing, and normally ultrasonic cleaning, non-flammable products should always be used, and both of those are due to safety reasons. So consult with your product and your equipment vendors, as well as your safety team. Another way to compare and contrast the flammability values when doing your reviews is the GSH flammability rating that's available on the SDS documents. Materials compatibility. Oh, sorry. If you're replacing one product with another, it's always a good idea to run compatibility on your various plastics, seals, O-rings, to ensure that there's no degradation by the new product or changes that you may have made in your process. Plastics can haze, craze, crack, dissolve. Elastomers and seals can swell, shrink, get soft, sticky. They can even be made brittle because the plasticizers leach out. If you're using a water-based product, be aware that corrosion can form from inadequate product rinsing or incomplete drying on the parts. Now, your chemistry provider can give you a good idea of what materials may be affected by the product, but testing is the only way to make sure and to make that determination, and we can help you with that also. So for performance, oh, I'm sorry, the other specifications. These are the boiling point. That's most commonly used to set up a vapor degreaser. You'll need to change a lot of your settings, and that's going to determine what these settings may be. Higher boiling point actually can help remove like waxes and the waxier, heavier greases. Surface tension is another physical property that you might want to look at. That allows the solvent to flow under some of these low standoff components, in and out of weep holes on certain parts. So that's an important property. The cleanliness requirements, whether that be military performance specification, an internal SOP, could be customer driven. It could be a IPC specification like J Standard 001, A610, whatever it is, document that and make sure that you're comparing all of these products to the same specification. Okay, performance. When you're doing performance testing, you'll need to establish, again, what cleaning criteria and requirements are necessary. And so, like I said, document all of this. Generally, the variables that you're going to see in your solvent evaluation are solvency of the product, differences between your products and solvency, and the things that you can control, such as time, temperature, and agitation, if you have agitation like ultrasonics in your vapor degreaser or whatever. Depending on the type of product, we recommend starting with the current parameters if possible. And your provider can also give you some starting points based on their own product knowledge. For instance, in vapor degreaser, settings on the unit will need to be adjusted to the new product. And really, that's about all you can do for that. When doing the performance testing, you'll probably need to adjust your zone times, the dwell times, your different zones, the number of cycles will need to be determined. If it's allowed, your wand use and your ultrasonics parameters will also need to be established. Now, the chemistry provider can generally help with the setup and the performance testing ahead of time, and that can give you a good idea of where to start. And that'll save quite a bit of time on your part, but that's in a laboratory setting. And it's still going to be imperative on you to test in your facility, with your equipment, with your chemistry, and to remove the soils that you generate in your process. Because laboratory are controlled settings. So that's really about it. And I'm going to turn you back over to Kevin for some more information. If you have questions, I'll be happy to answer those at the end of the session. And Kevin, take it away.
Thanks, Pierce. So we're, like Pierce said, I just have a few more slides and then we'll get into the questions. So you knew it was coming, okay? We're a manufacturer of chemicals, of solvent cleaners that replace N-propyl bromide. So I've got to get into the commercial side of things, so my apologies. But Techspray has literally at least a dozen different formulas available to replace N-propyl bromide. Okay, so this is not a new issue for us. Techspray has been going after N-propyl bromide, trying to move customers away from this toxic chemical for the past 20 years. Okay, so we've got a lot of experience at this. So the two main brands, if you will, product brands that we offer is one is Power 4. Power 4, there's a maintenance cleaner and there's a flux remover. Okay, this is going to be our closest equivalent to N-propyl bromide in terms of performance and cost. Okay, it's not really for the sensitive type of plastics, but generally speaking, as Pierce was talking about, if you had those kind of plastics, you probably weren't an N-propyl bromide anyway. But this is going to be our highest performing option. If you do have the sensitive plastics or some really strict requirements in terms of environmental requirements, things of that nature, we have the Precision V line of solvents. Okay, so then we can move you to that. Those are generally going to be more expensive, but a lot of customers, as they are moving away from other chemicals and AK225, they may have moved to N-propyl bromide temporarily. Well, we can get you back into the higher precision type of cleaning. So that would be with our Precision V chemicals. Okay, so also want to offer to you our tech lab. Okay, so it's overwhelming. Okay, you got to make this change to a different chemistry. You've got your full-time job, right? Producing whatever you produce for a living to make your revenue. Well, we can help with that, okay? Techspray offers our tech lab. It's an in-house application lab for qualification testing and problem solving. Okay, you've got me to answer questions. You've got Pierce. We've got a full lab of people, okay, to help you with this. And that's where these forms really come in handy, because you can provide us these forms. We can fill them out, consult with you. We have a vapor degreaser in hand. We have an ultrasonic batch cleaner, so we can do in-house testing without causing delays in your own process. Okay, so you can keep doing what you do, and we can do that initial testing for you. Of course, we can do manual cleaning and aerosol as well, document the results, feed them back to you. You can duplicate in your own facility, and then we can finalize this. We have chemists, application specialists on staff, of course, and we can even customize products. Okay, this would be for a higher volume if you're using a lot of it, but we can actually do customization if it's required. Okay, so finally, questions. Okay, you can see by this guy, it gets pretty overwhelming. So let's see, we got 3 questions. Can we get a copy of this presentation? That's from our sales guy, Bob Powledge out in Texas. Absolutely, Bob. And it looks like Bob asked all the questions. Okay, give an example of a flammable product comparing its flammability to the flammability of IPA. Okay, many customers use IPA, then tell us they can't use or don't use flammable products. Okay, I think what he's getting at, and Pierce, you can of course add to this, but customers sometimes get in the mindset where they have to stay non-flammable, and they're paying a premium to do that. And it really comes to the forefront when they have to make a change from N-propyl bromide. Okay, so then all of a sudden they have to check out the replacements, and to meet the requirements, all of a sudden they get a price bump. They step back and ask, do you really need to use a flammable product? Because we've had time and time again customers that say, yes, it's required, and then over here they're using isopropyl alcohol or fluxes that are isopropyl alcohol based. Okay, so it's a function of, yes, we all would like to have non-flammable products, but there is such a premium that we do suggest you do a study just to make sure, step back and make sure that's still required. Now, example of a flammable product, isopropyl alcohol certainly is an example. We got hydrocarbon-based cleaners as well. They are great with plastics, okay, great cleaners, much stronger than isopropyl alcohol, and much, much cheaper than any non-flammable solution, okay? So just keeping that open, and so I think that's where Bob's getting at there. I got one from an anonymous attendee. Do you have a list of nPB trade names? That's a real good question. We can rattle off a few of those. Now we've got certainly Microcare has got what's it called? Bromopropane is the general term for nPB. Pierce, you remember what the Microcare one's called?
I don't remember what they market that brand name under, but there's Linium, there's Aerotron, there's a number of different trade names, and they're all N-propyl bromide based. Generally, they all have a stabilizer package. Some may be just nPB with a stabilizer. Some they may have an alcohol incorporated into the formula. I didn't even I wish I had kind of copied some of that information down, but
no problem. I'll send that list. We certainly have that available. So with the conclusion of this, I'll be sending other things to you guys that I promised you guys. And so I'll send a list of popular brand names as well for N-propyl bromide to help you identify those. The CAS number is the easiest way to identify it, because like any chemical, it's called 1-bromopropane, nPB, and propyl bromide, all kinds of different chemical names. Look for that CAS number that we gave you earlier in the presentation. And that's on the back of your can. You got, and you see that exploding chest, you got nPB, okay? Solvon is a company that sells a lot of, they're a leader in N-propyl bromide products. And so, if you're buying it from that supplier, there's a good chance you're using N-propyl bromide. Let me see if there's any other questions.
Yeah, you'll see, a variety of product names, but always look for that CAS number, because that is the ultimate identifier of what that product is or what it contains, if nPB is a constituent in that product.
Okay, so that's all the questions. We can wrap this up. So as I mentioned, Pierce and I are here for you. Okay, so if any questions come up, we get done and it pops into your head, you got my email. Okay, I've been emailing you the reminders and such. Just reply back to that. Go on chat. I'm there waiting for you. Okay. Oh, we got one more question before we go. Let me see if we can answer it. Oh, Bill Watkins is asking for a copy of the presentation. Yeah, we already covered that, Bill. You're going to get a copy of the presentation. So I'll send that with the email after this. So you're going to get an email from me that's going to have a copy of the presentation. You're going to have a link to the video of this presentation so you can watch it again and fill out any gaps that you might have missed. If you went to the bathroom in the middle of it, you can catch that. We're going to get more links to the forms that I already sent you, but I'll send those to you again. I'll get you a list of the different types of other brands, the different brands of N-propyl bromide. So that's what I promised you. And you're going to get a guide. We talked about a high performance degreasing guide. Okay, it's a PDF that's got some articles in it. So we'll send that to you as well. So a lot of goodies coming your way. If there's no other questions, we'll go ahead and wrap this up. I appreciate you all attending. And again, just going to remind you one more time, and I think I got one more slide. Yeah, here's the slide. Don't forget, Pierce and I, our job is to make your job easier. Okay, so if you're moving from N-propyl bromide, tearing your hair out, you can stop that. Okay, we're here to help you. Okay, we're going to answer your questions. We'll be honest, right? If we don't have the best solution for you and you're looking at other things, we're going to be honest with you. Okay, the idea is we want you to land in a solution that's best for you. Chances are we've got those solutions. Okay, we work real hard to do that, but we're here to consult with you and get you in the right solution. So we got Pierce, senior field engineer, so he could actually go to your facility. I'm on the phone, chat, email to help you out. So please don't hesitate to reach out. So everybody, good luck with the process of moving to nPB. Please fill out the survey. Let us know how we did, and have a good day.